And this report details the steps involved in the Quartus software to program the Max-10 FPGA. The particles aim to set up the Quartus for compatibility with various codes of FPGA. The configuration of Quartus software is vital to enable efficient program of FPGAs such as Max-10. Outlines the essential steps required to set up a Quartus for programming tasks and emphasizes the configuration process of multiplexer. Now I'm gonna be explaining the first code of the VHD. So the provided VHD code defines a multiplexer, or in short MUX, entity with 4 ports: A, B, cell, and X. A and B are inputs, ports representing the two data inputs to be selected by the multiplexer. Cell is another input for representing the select signal that determines which input gets passed to the output X. X is the output representing the selected data output. The architecture selection of the code, named behavioral, describes the behavior of the multiplexer. It utilizes a simple condition statement to select their input A or input B based on the value of the select signal cell. If cell is 0, input A is passed to the output X. Otherwise, if cell is 1, input B is passed to the output X. So it's a very short black box, as you can see. The code implements a simple 2-to-1 multiplexer using VHD. The multiplexer selects between two data inputs based on the value of the select signal. Such as multiplexers are commonly used in digital circuits for selecting between multiple data sources or performing various routing tasks. Well, now I'm going to be explaining the VHD of the MUX. So I'm going to be explaining this block of code here where it says begin. So it's very simple. This block of code simulates the operation of a multiplexer vector circuit. The code consists of a series of test scenarios. Each setting specifies the value of the input, vectors A and B, and the select signal cell. After setting these values, the code waits for a delay of 10 nanoseconds before proceeding to the next scenario, like in this part, in this part, in this part, and so on and so forth. In each scenario, A and B represents input vectors of 4-bit each. Cell represents the signal, controlling which input vector is routed to the output. By varying the values of A and B and cell, in each scenario the code tests different combinations of inputs and select signals. This allows for thorough testing for the multiplexer vector circuit's functionality under various conditions.
Well, now I'm gonna be explaining the physical part of this MUX. So this is the MUX of 1 bit, and it's a FPGA of Intel, the university program. So basically it has 3 inputs, which are A, B, selector, and one output, which is X. The output will be this LED. So basically if I pull this switch up, it won't start blowing. But if I move the selector up, now I can turn this LED on, but now the second switch won't work, so I have to pull the selector down, and now I can use the second switch. So that's all. Thank you for stopping by.
Now in the second part of this tutorial, I'm gonna be explaining how the MUX vector VHD works. Well, the explanation is pretty simple. The VHDL code defines an entity named MUX vector, which represents a multiplexer, or in short MUX, for a vector inputs. The entity has two input ports, the A and the B, and one select input port, which is the cell. Additionally, it has one output port, X, or type STD logic vector with a size of 4 bits, ranging from 3 down to 0. The architecture selection behavioral specifies the behavior of the multiplexer. It utilizes a conditional assignment statement to select their input vector A or B based on the value of the select signal cell. If cell is 0, the input vector A is passed to the output vector X. Otherwise, if cell is 1, the input vector B is passed to the output vector X. Overall, this code implements a 4-to-1 multiplexer for vector inputs, allowing selection between two 4-bit vectors based on a single select signal. Now I'm going to be explaining the MUX vector VHD. Well, I'm going to be explaining this block of code where it says begin. This block of code presents a series of test scenarios for a multiplexer circuit. In each scenario, the select signal cell and input vectors A and B set to specified values, followed by a delay of 10 nanoseconds, as you can see. These scenarios aim to simulate different input combinations and observe the behavior of the multiplexer circuit under various conditions. The scenarios cover a range of input validations, including different binary values for A and B, alternating values of the select signal cell. Each scenario represents a distinct test case, allowing the comprehensive testing validation of the multiplexer circuit's functionality. It will be validating cell 0A1001, B0110, wait for 10 nanoseconds. In other words, it will be 9 and 6, and it will be changing over time between 10 nanoseconds of each case, as you can see, and that's all.
Well, now I'm gonna be explaining the FPGA university program. Well, now is the second part, which involves the MUX vector. And in this case, it will be with 4 bits, 0 down to 3. This means that if I pull this switch down, the 4 LEDs will turn down. They are off. But if I turn this up, they will turn up the LEDs. Now if I turn down, let's see, this switch, it will display off these LEDs. If I turn down, let's say this, it will be off, like so. And if I put down this, it will be showing off. And if I pull down selector, finally this LED will be off. And also I can turn these LEDs with these switches, as you can see. And that's all for today. Thank you for stopping by.